Alright, so these sections are pretty much similar, so I just put them together. The first section is just scatter plots and linear correlation, and the other section is regression. But pretty much they go hand in hand. But so that's why I put them together. So nothing too bad when it comes to it. So essentially, what's going to happen in this one is we want to see if there's a relationship between two data sets. So in order to do this, we want to see what type of relationship we actually have. So what I mean by a relationship between one or two. So for example, is if one grows, so does the other one grow, or does one grow and the other one decrease, right? So that's when my relationship itself, things like that. And the funny thing is, because we're in stats, right? This goes hand in hand back in algebra, because all those graphs you saw in algebra, like the bell-shaped curve, the U-shaped curve, the parabolas, inverted ones, all that correspond to here, because that actually tells us a nice relationship between the variables itself. Okay, so when it comes to it, the first we want to talk about is the strength of the relationship, and we'll talk about that in a little bit. How you correlate when it comes to that. But before that, we want to talk about the different types of correlation we talk or relationships. So whenever you see correlations, that's just another word for saying relationship, if that's easier to understand. Okay, when it comes to it. Right. Right. So the first thing is we can have a positive linear relationship. So a positive linear relationship is kind of like this, where if just like an xy plane where this is the x variable and this is the y variable, right? X data values, y data values, and we kind of have a linear relationship going up. So if I can make a line roughly through all of them, and it's going straight up like a line, hence why it's called linear positive. So a positive linear relationship. Okay, we can have opposite the other way, the opposite way. So a negative linear relationship, when you meaning as one increases, the other one decreases. But again, it goes linear. It goes, again, kind of like a line. So I can make kind of like a line going straight down. Hence why it's called negative linear relationship. Okay. The other type one is a non-linear correlation. So essentially what this saying is it's non-linear, but it does have a relationship. So speaking of the parabola, this will be considered a non-linear relationship or a parabolic relationship, because notice it kind of looks like a parabola inverted, right? So just because it doesn't linear doesn't mean it has a relationship. But in our cases, we're going to be talking about these two the most, since it's an intro class. So it's either going to be positive or negative, or one of the most interesting parts is no relationship whatsoever. So what does no relationship mean corresponding to these two? So no relationship means it's literally a big old blob. There's no line, there's no curve, or nothing that can actually make it look like it's a nice smooth curve or anything like that. So this would be considered no relationship whatsoever. So it's just, blob, big old blob everywhere. Okay. But again, what we're going to be dealing with is these three essentially. So if we have positive, negative, or no correlation whatsoever. So non-linear goes into higher stats itself. Okay. And I gave you this portion here, right? So get a little relationship. So what we're going to start with is something called the linear correlation. So fancy word. So linear correlation, right? So first off, we have a major definition when it comes to the section. It's called linear correlation coefficient. A lot of words, and the good thing is it's abbreviated to a simple little r. So when you say the linear correlation coefficient, or R for short, so little r, okay? So that's what that represents. So the linear correlation coefficient, or R for short, measures the strength of the linear correlation between the paired x and y values in the sample. The key thing is it just measures the strength, and we'll talk about what it means in a little bit. Okay, so first off, in order if we can have a linear relationship, there's three things we have to figure out. So the first thing is you have to have a simple random sample of both samples. So both random samples are random. Second thing is there's a visualization on the scatter plot. There's an actual straight line. So in other words, we have to do a scatter plot and see, can we have a roughly a straight line between them, either going up or down or not at all. Okay. And then three, any outliers must be removed. So way back in the day, we talked about outliers, right? So outliers are, data values are out of the norm. So for sure, we got to take those out first, because we're assuming those are going to be negligible, and they'll go from there. But in our cases, we're not going to have any outliers itself. So don't worry about that. Now, once all three conditions are completely satisfied, then we meet the criteria to actually find the linear correlation coefficient. So in other words, finding R itself. Now, this equation is the worst of the equation in stats, and it looks like this. Let me run down. That looks horrible, right, when it comes to it. Now, I'll just say these out loud so it comes to it. So this is the mean of all the x values. This is the standard deviation of all the x values, and these are the individual values themselves. Values, okay, that's that portion. And same thing applies over here just for y. So these are the mean of the y variables, standard deviation of the y variables, and again, these are the y values themselves. And once you do this for every single one, you're going to multiply them, add them all up, and divide by n minus 1. Now, hopefully you look at this and like, this is kind of ridiculous. Well, the good thing is you'll actually, well, in this portion, probably never have to actually calculate r, which is the best part. A calculator usually does this or be given to you in the question, which is the best thing itself, right? It's a horrible equation for a reason when it comes to it. It's just there to scare you in this case. Okay. So now that we know how to calculate r, and then again, right, you're not technically in the calculator; it's going to be roughly given to you in some format. But the main concept of what what you're going to be caring about is what it actually represents. What are the properties of r that actually represent? Okay, and that's the most important thing. So the first thing, the first major property of r is between -1 and 1. Okay, so it's bounded between -1 and 1. Okay. The second thing is if r is a negative number, so if r is a negative number, it has a negative relationship, which makes sense, right? And if r is a positive number, therefore we have a positive relationship. So kind of makes sense, right? So the sign of r tells you if it's a positive, so meaning, right, positive relationship, negative relationship, going up or down, right, when it comes to it. Now, number 3 is a very interesting one. So the closer r is to -1 or 1, the stronger the relationship is, and the closer r is to 0, the weaker the relationship actually is going to be. So I'm going to give you guys a little template here from -1 to 1, and here's 0. Okay, so the closer you are to here or here to the endpoints, the stronger it is. So the stronger the relationship actually is going to be. Okay, the closer you are in the middle of 0, so right from negatives and positives. So in here, the weaker the relationship actually is going to be. Okay. Now, if you guys want to cut off, you can say like 0.5 is going to be your cutoff, but you're never going to have something that close to the center. You're going to have something, over here, and over there, right? So it's going to be drastic when it comes to it. So let me give you an example when it comes to this. So let's suppose we have r is equal to negative 0.951, for instance. Okay, so if r is equal to negative 0.951, well, that could be considered a strong or weak relationship. Hopefully, say strong, right? It's closer to -1 than 0. Okay, therefore, not only is it strong, but is it positive or negative? And it's going to be negative, right? So how are you going to do this type of portion, or when it comes to these questions, is you're going to have to answer two different things when it comes to r. Is it positive or negative? And is it strong or weak? So there's two apertures to essentially when it comes to r itself, okay? So essentially here we'd say this is a strong negative relationship, or a negative, or yeah, strong negative relationship. Another example we would say is a 0.041, for instance. So 0.041, okay? Well, 0.041 is closer to 0, correct? So therefore it's weak. However, it's also positive, right? So this would be a weak positive relationship. So that's it, right? The sign tells you if it's, plus or minus, and the number tells you if it's, weak or strong, depending on where you actually get itself. Okay. All right, and the next criteria is R is not affected with a choice of X and Y. We'll talk about that in a little bit. And then R just measures the strength, like I said earlier, right? Just how strong it is, strong or weak when it comes to it. And again, lastly, like I said earlier, R is a sensitive outliers, hence the reason why we get rid of them. Okay. So let's just do a quick little example to see how that corresponds. So let's suppose we know what R means already, right? So the question is, well, what do these X and Y values represent? So they're going to give you two different data sets, the X's and the Y's, and they're going to be paired, so they're never going to be one more than the other. Okay, so that's going to be a hint. Now we want to figure out is, do we actually have a linear correlation, right? Because notice none of these said it's linear. That's a key thing. It just told me it was plus, minus, strong or weak. That's it. It doesn't tell me if it's actually linear, so a line or not. That's what we're going to talk about now. How do we know if it's an actual line or not? Okay, so to do this is actually one of the easiest ways when it comes to it. So we're going to use our formula sheet to help us out when it comes to it. So go ahead and take your formula sheets out, and we're going to find something called the critical value. So a lot of critical values, right, in stats when it comes to it. So to find the critical value, all we need to do is find n. Okay, that's it. There's only one number we care about. And n is the number of paired data values we have. Not the entire set, but the paired. And we'll talk about that in a little bit as well. Okay. And in our case, alpha will always be 0.05, which essentially is not going to help us out anyways, but just in case you have a different formula sheet, it's going to help you out when it comes to alpha. It's going to be 0.05. Okay. All right, so let's do the example on the next video.